So we'll look at these, and I have added, when I say lesson 1 through 3, 1 through 4, 1 through 5, hopefully I have limited the questions to that range of days. That's not always going to be the case. Sometimes I say, oh, I think that we've covered something that we really hadn't, but you can go back and do these on your own if you would like at some point. So, and this is one I know we didn't talk about. SMP is symmetrical multiprocessing. And what that means is, that's all says symmetrical multiprocessing. Symmetrical. Well, it's symmetrical multiprocessing. I did a copy and paste. Okay, that was processor. See how my brain works backwards, not multiprocessor, multiprocessing. What that means is we have multiprocessors, 2 processors, for instance, in a motherboard, and there are multiprocessor motherboards. Even though we've gone to multi-cores, there's a limit on the number of cores. Big servers are going to not only have multi-cores, they're going to have more than one processor unit in it. And what symmetrical means is that each of the processors share the load equally. We can have asymmetric multiprocessing to where we have one processor do more of one thing than the other, but those things. So now then, we'll get into that need some help. The motherboard form factor, it's 9.6 by 9.6 inches, is B mini ITX. I'm just going to put your guys' answers in here unless we can't get one. Which motherboard is most likely to be encountered when dealing with consumer PCs? We'll go with C. We'll see. We'll see what they are. I'm going to try to stay out of it tonight, because I had a student one time say, you answer your own questions, so I'm going to try not to answer my own questions. A small form factor PCI slot intended for small form factors PCs is a Okay, we'll go with A. And this one, I think the question and the question answers itself, doesn't it? PCMCIA is a card that goes into it, got an express card and those things. The PCIe we wouldn't consider a PCI; it's considered its own entity there. Which type of chip is used to control the functions of the motherboard? A again. You guys need to help these two ladies out. Which of the following feature sets of a power supply should be installed? And we're going to select 3 in this one. We go with a 24 pin. We got a C, a D, and an E. C and D. Okay, I said I'm going to answer the question, but I'm going to ask a question. Remember, the 24 pin actually has the little kind of tear off edge to it. E, I'm going to go ahead and mark these. Do you still want D? Help me out. Do you guys still want D, or do you want one of the other ones? Okay. So Keithia still wants D. A customer wants a computer for performing a single-threaded task as quickly as possible. Which of the following CPU characteristics is most important? A. Okay. A technician is building a new PC and notices that it has 8 DIMM sockets labeled 0 through 7. 4 are white and 4 are blue. Which of the following should the technician do first? Installing the 4 whites, installing the 4 blues. Consult the documentation, install the memory slots 0 through 3, or fill all the memory slots. C, let's see, C. Let's look at the documentation. When you do these things, the documentation will tell you what order that the memory slots should be filled. A technician's building a workstation that is used as a home theater PC and will sit next to the audio receiver. Which of the following form factors would the technician most likely use because of its size? We'll go with D. Technician is troubleshooting a desktop that is having intermittent issues with locking up and system errors. The technician suspects that the problem might be that not enough power is getting to the motherboard. Which of the following tools would the technician use to determine if the hypothesis is correct? Postcard, loopback, multimeter, or cable tester? D, cable tester. I got a cable tester, a cable tester. We'll do that. Do you know what a cable tester does? We haven't talked about those yet. A cable tester is to test network cables, test the continuity of network cables when you put the RJ45 connectors on. So you want to change your guess on this one? Okay, Maria, okay, we'll go with C. I think that's a good choice. Multimeter checks voltages. A technician receives a call that a client's PC is not booting after a recent test of the building's backup generator. When the technician arrives, it is discovered that once powered on, there is no output display or post beep codes. This sounds serious. Furthermore, after 15 seconds, the system's fans begin running much louder and faster. Which of the following is the most likely issue? Okay, I got an A, so we'll go with an A on that. And I agree. I mean, that the key here is that they did a test, and after you did something, it doesn't work. Well, that's what probably caused it. A PC has been randomly rebooting several times a day. The technician checks the case for overheating and finds the fans appear to be operating normally. Which of the following should the technician check next? Swollen capacitors, the disk drive to determine if it needs to be defragmented. I think that I'm gonna say I got an A. I got a couple of A's here, so we'll go with an A on that one. Swollen capacitors, and they do get that way, and then not a fun thing to do. See, we're slowly building our attendance. There we go. Okay, so which of the following components of the motherboard is responsible for communications between the CPU and the RAM? D, the North Bridge. Got that one right. A technician has a work order to install a USB 3.0 expansion card into a PC. The expansion card has a PCI Express 1.1 compliant card and motherboard, and the motherboard has one PCI Express 2.0 slot available. What's going to happen? What's the capability? And Maria wants the D. She's got D, and Barb's got D, so we'll pick D. On an ATX motherboard, the 4-pin auxiliary power connector provides which of the following? Additional power to onboard devices, power for the PCI-X peripherals, power for the South Bridge, or additional power to the CPU voltage regulator. We'll go with Louis A. You ready? 67. By the way, 70 is the target on this one. So the motherboard is a 9.6 by 9.6 is the micro ATX. Jacob is having an issue, I guess. Now we go down here. Which of the following feature sets on the power supply? In this one, we want a high, let's see, C, D, and E. 24, yeah, our response was C, D, and E, and B, C, and F. We want a high number of connectors. We want a lot of power connectors for a power supply. 24 pin, yeah, we need that. We don't need the 20 pin if we've got the 24 pin because it has the addition which actually will come off and make it, the 4-pin addition will come off. It'll make it a 20 pin connector if we need that. And then they want the dual 12-volt rails. Technician, a home theater PC, B, a mini ITX. I think I'll have to go back and check that one. The USB, it's going to install correctly, should function because PCI Express 2.0 is backward compliant, backward compatible. And then the 4-pin auxiliary down here didn't tell us what the answer was, huh? Answer A, answer D, answer D, and we picked A. Okay, it did tell us what the answer is. The auxiliary power to the CPU voltage regulator. So those are available to you, ecpi.com/A+. Do those if you get the opportunity. You get bored over the weekend, give those a shot. So before we go, or any questions, and we got the one, we'll look at that lab after we get done with this, if that works for everybody. Let me save this because they'll get upset if I don't get it in on time, and then set it up in case somebody else shows up. So tonight is managing data storage. And the first thing we're going to talk about is RAM. RAM is really called primary storage. It's temporary storage, but it's primary storage. It's the first, it was the first storage, I guess, is what we would say. And the secondary storage is going to be the hard drives. And we're going to look at some stuff. We're going to talk a little bit about RAM or RAID here when we get on. I want to try to demonstrate on a virtual machine on a Windows server, create a RAID, and then what are the impacts of doing that. So we're going to identify RAM types and features, troubleshoot RAM issues, install and configure storage devices. And storage devices are a big deal, and reliable storage devices are an even bigger deal, and that's why we have RAID. You probably heard the term. We'll talk about which ones have redundancies to protect our data and which ones maybe speed things up if you're, for instance, a gamer. Or if you have, well, I think the example they give is you're doing video editing where you need a pretty fast hard drive to do those things. Configure the system firmware, troubleshoot hard drives, and RAID arrays. So the RAM module, and we've seen that, and you're probably sick of seeing that, but the RAM module or memory module is printed circuit board that holds a group of memory chips that act as a single unit. The way they act as a single unit is by connecting to the motherboard, obviously, and have all these connectors that have individual lines. And then the bus size we talked about, the 64-bit and the 32-bit bus, the lines here, and then they get ones and zeros from actually going from the CPU. CPU can talk to it, send it to the hard drive. Technically, the CPU is going to talk to what's called the cache memory, which is, we'll see a little slide about it, or at least a bullet about it in a minute, which is very high speed memory and very expensive memory. A little bit of it, and it's usually on the CPU module, and then it talks to the RAM. RAM gets stuff out of the hard drive, sends stuff to the hard drive, so that the instructions and the data get from the permanent storage, the hard drive, into the CPU to execute the commands that we want. So RAM, random access memory, two types of memory, RAM and ROM. Random access memory and read-only memory. The different from the ROM, and the ROM was what we had for our BIOS. All the PROM, the ROM, we have PROMs, EPROMs, and EEPROMs. PROM is programmable read-only memory. The original BIOS chips actually had a piece of tape over a little window. You couldn't flash them like we do today with the EEPROMs or EPROMs, erasable programmable read-only memory. EEPROMs are basically SSDs. And oh, by the way, as a side note, SSDs do eventually wear out. They have X number of reads and writes, particularly writes, just like everything else does. But random access means that the memory addresses are dynamically allocated. What that means is that we can go pick out something from the RAM. We don't have to look at the whole thing. Much like the hard drive. The hard drive is a accessible or a random access, to where the head goes out, gets a specific spot on the hard drive. Different from the ROM, pre-assigned codes. What roles RAM play provides the CPU with the data to process. Keyboard entries are sent to the RAM addresses. Hard drive programs are sent to the RAM addresses. Network data, web pages, all that stuff sent to the RAM. The RAM stores that information and then provides it to the processor as it's required. Faster than the storage, like the hard drive and the USBs. Installing more RAMs, the easiest way to improve the system performance without investing in a new system. And it is the quickest way to do that. When I had to buy it, I had to buy a new machine because the other one just quit, totally quit. I was looking for one that had at least 8 gig of RAM, and they had one that's pretty reasonable. So as much memory as you can get in, particularly with a Windows system, as much memory as you can get onto the motherboard and afford is how much memory you want. And that goes back again to the motherboard documentation. How much can it actually hold? So the types of RAMs: static random access memory, and I alluded to that a little bit earlier, also known as L1, L2, and L3 cache memory. So this is the really, really high speed, and it is higher speed than the down here, the next one, the SD-RAM or the DD-RAM, which we have in our RAM slots. The SRAM, the static RAM, the cache, we're not going to see. It's going to be part of, if you have a really old motherboard, you might see it, but it's going to be part now of the CPU module, which will be inside of it. Does not require a memory refresh, and that's like, okay, where did that come from? RAM that we have in the memory slots, what we consider RAM, has to be refreshed regularly, or it's transistors and capacitors. If it's not refreshed, the electrical charge drains off of it. So the RAM has to be refreshed. It's dynamic RAM, and that's why that's part of the dynamic term, is it loses its charge as it sits there. The static RAM is just that, it's static. It does not lose its charge. It can be changed, obviously, but it does not have to be refreshed. Built into the CPU, physically large memory, fast, but extremely expensive, not generally upgradable. It's usually a part of the CPU module itself. SDRAM, synchronous DRAM, synchronous dynamic random access memory. PCs before 2000 use this. Constantly refreshed, random access. It's synchronized to a common clock. and is rated by the bus speed. 266 megahertz bus, for instance, uses PC 266 SD RAM. So older machines are going to have SD RAM. What we're using today, and this is the RAM types continued, this is what is in the newer machines, is DDR, is double data rate SD RAM, rated by throughput in megabytes per second. For instance, PC 2700 means that it can deliver 2700 megabytes per second. DDR2, and we're just going to go basically through these things and increase the speed. DDR, DDR2, DDR3, DDR4 is where we are now. DDR2, twice the speed of DDR, not backward compatible, and that's going to be a theme for each of these, and I got some pictures here in a minute, couple of minutes. That's about 1, 2, 3, about 4 slides down of how the physical differences, what the physical differences are in these different types of RAM, so that you can't put the wrong type of RAM into a RAM slot, RAM random access memory. DDR2 twice as fast as SDRAM. Next generation DDR, twice the speed, not backward compatible. PC2 is the prefix number for the DDR. PC2 2700 would be DDR2. DDR3 240 pins, twice as fast as DDR2. DDR2 chips are the same length as the DDR, but they won't fit in the slots. There's a little notch in them that they keep moving around so that you can't line it up. It physically won't go into the wrong slot, which is a good thing because people used to put the wrong memory in the wrong slots before those kinds of things happen. DDR4 faster than DDR3. It's a lower voltage, lower power consumption, less heat, has burst access. It has 288 pin connections, notches in a different location, not electrically compatible with the different ones. And we looked at this picture a little earlier when we talked about these things, but I think it's worth bringing it up again. See if I can get my pen going here so that I can make a couple of marks. But standard or SDR, static dynamic RAM, the clock rate, when the clock rate in this particular RAM only takes an action, does what it's supposed to do on the rising edge of the clock. The way we get the double data RAM, or the double data rate RAM, is the clock in one clock cycle. It does its thing on the rising as well as the following edge, so that we get 2 bits of data out of it, where in the SDR, the single, we only get 1 action or one data transfer. DDR, we get 2 double data rate. This is charts, and this is out of the Professor Messer study guide, so you don't have to take it off of the slide. But if you look at these things, the memory clock speed, the top one is DDR. I cut off the DDR part of it. The memory speed is 100 megahertz. The I/O bus speed is 100 megahertz. The DDR speed, DDR 200. Transfers per second, 200 million. Transfer rate, you use 8 times the transfer rate, 8 bits to get bytes. So the transfer is going to be 1600 megabytes per second, and it'll be called PC 1600. PC is going to be DDR, and on down to the DDR2 100 megahertz clock. The I/O bus clock here, instead of 100, is going to be 200 megahertz, twice as fast. DDR2 400 transfers per second, 400 million, and we multiply that by 8 to get megabytes per second, 3200 megabytes per second. It's going to be PC2 3200, and the 3200 represents, obviously, as you can see from this thing, the transfer rate. DDR3 100 meg, double again, the bus 400 megahertz. The speed DDR3 800 million transfers per second, again multiply by 8, 6400, and it's going to be PC3 6400. So the way it's named represents the type of RAM it is, PC3 DDR3, and then the number after it is going to be the speed. Frequently, a motherboard can take more than one RAM type, and that's why you got to look at the documentation. But when you do that, you need to match up the speeds of the RAM. The sizes, not necessarily, but the speeds, it's a good idea to have those matched. RAM specifications to know, and this is from a different vendor, and this was their title, RAM specifications to know. Module type, the number of pins, 240, 184, 168. Number of RAM slots available for modules, the chip type, DDR2, 3, and 4. Speed needs to match up as a multiple of the motherboard front side bus speed, measured in nanoseconds or throughput. The CES or CL timing should also be the same on all modules to avoid lockups. That's going to be something that will be on the label of the RAM. And the CL, I think it goes 1 through 5 or something like that. When you order it, it'll do that. I guess the easy part of RAM is the vendors, the online vendors at least, that sell RAM, have a couple things. One, you can put in the specifics of your machine. It'll tell you what RAM it'll take. Most of them also have a little app that you can download and put on. It'll check it to tell you what RAM that you should get so that you're buying the correct RAM. Error checking, ECC, optional, used. It says used by most servers. It can be used by servers, and they're basically the only ones that are going to use error checking RAM. Error checking and correction, that's what the other C is for. It can actually correct errors. We're going to talk about one that parity, where it just checks to see if there is a problem. The number of modules needed per bank, dual channel, triple channel, quad channel configuration. We haven't talked about that yet. I've got a couple of slides on those in a minute. These are the different ones. We got the DDR module here, the CL3, the DDR2, and then the DDR3 and the DDR4. And I guess maybe a little bit difficult to see, but if you look, and this one over here shows the slots and how they line up. DDR3, we have a slot way over here. The 2 and the DDR are relatively close, but there's a line here that I probably will mess up. It goes down this way, and the other one starts here, so they're not quite in alignment. They look pretty close, and if you look here, they are really close, but they're not close enough to where you can get one. Yeah, I can't even draw a straight line anymore. I did something to this thing the other night when I was still can't draw a straight line, but they don't line up. And then these obviously move around a lot. We got this one again here, the DDR4 looks close. It is close, but it is different. I don't think those are big enough to see. This is PC. This one up here, PC 3200, 256, and there is the CL3. 256 DDR, 400 megahertz. All of the specifics will be on the label, and they usually say that if you take the label off, it will void the warranty on the RAM. So doesn't hurt anything to leave it on, and then if you need some later on, all you got to do is look at the label to see which one that you need. DIMM, dual inline memory module, and it's 168 pin, 184 pin, 240 pin. Dual refers to each side of the module having a different pin out. What that means is it's like having two DIMMs in there. They're separate. So the pins on the front side talk to the RAM chips on the front side, and the pins on the back side talk to the DIMM, talk to the modules or the chips on the back side. Small outline DIMM, SO-DIMM, is one that is used in laptops, notebook computers. Compact version of the standard DIMM. And when you look at it, the SO-DIMM up here at the top, and then the regular DIMM, DDR2 SO-DIMM and DDR2 DIMM, DDR3 SO-DIMM, and if you compare those two, the slot for putting it in the memory in the memory receptacle is in a different location for the SODIMM, also to keep you from putting the wrong memory in the wrong slot. Let's see. So I got a note here that says, explain to the students that SODIMM or small outline DIMM memory is used primarily in laptop computers, but some mini ITX boards also use it. Some printers use SODIMM memory for expansion or to change the printer emulation. For example, to add PostScript support. PostScript support, we're talking Apple's. This is another one from a different vendor that this is their title. Know these before taking the exam. RAM type, SDRAM, DDR, DDR2, DDR3, the number of pins, the common type and speed, and then the defining characteristics of them. And this again is in the presentations, which are in the in that Dropbox share. DDR RAM types: DDR, double data rate, synchronous DRAM, transfers data at twice the clock cycle, and we've looked at that because it does an action on the leading edge as well as the falling edge of the clock itself. The DDR2 increases the data rates over the DDR, require 240 pin DIMM slots, and then the DDR was 184 pin slots. DDR3, twice the DDR2, use 30% less power. Like DDR2, there are 240 pin slots, but again, none of this stuff is backward compatible. So the different notches, I've been saying slots, but notches, I guess is a better term, in the modules themselves prevent us from putting the wrong one in the wrong area. DDR4, the newer machines are going to be using that. 288 pin connections. Different location, not electrically compatible. None of these things are. Modules typically include attached heat spreaders or heat sinks. It's going to be a metal cover over it, and that all that is for really is the heat spreader spread out the heat is for it's a heat sink, heat shunt to do these things. RAM speed. Mixed speed causes all modules to work at the slowest module speed if we do those things, if we should do that. RAM types, not backward compatible. Definition of the MT per second, mega transfers per second, is a measure of the bus and channel speed in millions of effective cycles per second. The reason I put that in is we have the mega transfers per second over here rate, which is a little different, not a whole lot, but the peak transfer rate and it's a rating the actual delivered speed rather than the frequency of the clock when you look at those. Single-sided versus double-sided. Single-sided, everything is accessible by the PC. The chips can be on one or both sides of the RAM module, but there's only one, and let's call it one rank or one bank of machines. The double-sided has two banks of RAM where only one bank is accessible by the PC at a time. Two different sets of memory, but only one's accessible at the time. Chips are on both sides of the RAM module. We got some one time that some of it was double-sided, some of it was single-sided, and depends on how the memory is manufactured. Sometimes a double-sided will work in a single-sided, but it's unlikely that a single-sided will work with a double-sided, or if it does, it's going to regress everything to the lowest common denominator. And down here in this little chart, we have ranks, the number of 64-bit wide data areas. So we have a single-sided module has a 64-bit wide area, a single rank. Double-sided, 64-bit data area, single rank. Double-sided, but we have one rank on each side of the module. Double-sided module, I guess I messed that one up. Double-sided module, 64-bit. double-sided module with 2 ranks. It has a front and a back 64-bit wide area. And then with the 4 ranks, the front's got 2 64-bit wide areas and the back's got 2 64-bit wide areas. The reason that these things can happen and they increase the speed as the manufacturing has gotten better and better, then we can make the components smaller. Smaller they get, the faster they get, because they have less of a distance to go, for one thing. Then we going back to ECC error correcting, ECC and non-ECC. ECC detects and corrects data on the fly, and some servers use, I won't say all servers, because we had servers, some did and some didn't have ECC memory. ECC memory is going to be more expensive, going to be more reliable. Uses several bits of data of the data string to check for errors. It will say ECC on the memory itself. It'll specify that it's ECC memory. Upper end systems, high-end workstations and servers. Not all systems use it. More expensive, so we put it in servers. It looks like ECC, so if you have both non-ECC and ECC, keep them separated so that you're not using the wrong memory in the wrong areas. The non-error correcting is standard desktop for the PCs. Can be used with parity, and we'll talk about parity in a minute, what it means to detect errors but cannot correct errors. So parity memory, non-ECC may be parity, may not be parity. Early on, when we had lots of memory errors, and we don't have that many anymore, a lot of memory was parity. RAM configurations, these are the channels that we were talking about earlier. And what we're really talking about here is how many DIMMs can the machine, can the computer access at a time. In a single channel, slowest configuration, because a memory controller can access 1 DIMM at a time. Dual channel, 2 DIMMs at a time. And this is where putting the DIMMs into the slots in the proper order that the documentation calls for comes into play. Single channel, dual channel can access 2 at a time. Triple channel can access 3 DIMMs at a time. So all of these modifications, changes, upgrades didn't change what the computer did, but it sure changed how it did and how fast it could do those things. And quads, it can access 4 at a time. This one is setting up a dual channel. The pair of DIMMs in the channel must be equally matched, size, speed, features. Manufacturer is not necessary, but it's a good idea to have the same manufacturer. So, and here it says DIMM in channel A slots, and if you look at the channel A slots, it's going to be this DIMM and this DIMM. They're not consecutive most of the time, and that's why when we've seen these things, you'll see black slots, a black slot, blue slot, black slot, blue slot, to pair these things up. So the A channels and the B channels. DIMMs in the B channel are same way, that we have them in skip a slot sort of arrangement. Let's see, setting up a triple channel. It has 3 of them. The 4th slot in the triple channel is going to be empty, and again, whatever the documentation says is the way that you want to fill these slots. 3 matching with matching DDR3 DIMMs, and again, matching back to matching size, speed, features. Manufacturer preferred but not necessary. Parity. Older error checking method that's used in RAM to detect errors that occur during the transmission. Uses a single parity bit, an extra bit. Each byte's going to be 8 bits, and then we'll have an extra bit for parity if we have parity memory. It doesn't do any correction. And again, it says it's seldom used except for server machines. Non-parity relies on the other system components to check the RAM, and that's what we typically use. But if we do have parity, what even parity does here is we have we want an even number of ones in these things. So in this one, 1, 2, we have 3 ones, so we make the parity bit 1 so that we have an even number of ones in here. The issue here is that if we have some changes here, we'll go down here 0, 0, 0, see what I do, 0, 0, 1, 0. We have a 0 here. I think I got these messed up. This one's what I did is copy the same one twice. This one has got a problem because it should have a 1. This one would have been sent with a 1. 1, 1, 0, and then we put a 1 in for the parity. If we go down here, we have the sent, and if this one was a 1, when we get down here with a 0, we know that there's been an error. So that there's been a problem with it. The issue here would be if, see, we put a 1 in here to make it an even number of ones. If the error were this one, we had 2 ones over here and even, we would expect a 0 over here. So it's not 100%. It gives some reliability, but it's not 100%. And on any of these others, if we had an error that did this, then we would still be correct, but we would have errors in the data. So parity, some error checking, but not fantastic error checking, I guess would be the statement there. Buffered control chips helps the memory controller use large amounts of RAM. Servers could have buffered memory, and it's sometimes called registered memory. Often includes the error correcting circuitry. The non-buffered is what we're typically going to use in our computers, and it's less expensive and faster than the buffered RAM. Compatibility chart. It's the type of motherboard accept one type of RAM, DDR1, 2, or 3, and we have talked about not backward compatible. Motherboard, say, form factor will accept one type of DDR not compatible with each other. Speed, we can mix the speeds with the same RAM type. All memory modules will reduce to the lowest speed, and you need to look at the motherboard documentation to see which RAMs actually are compatible with it. Not everything's going to be, but if you have a multiple speeds available, then it's going to regress to the lowest speed module that you put in. The size, the amount of RAM on a module, you can install modules with different amounts of memory. The optimum performance is if they are matched. The CAS latency signal sends the signal the processor sends to the memory circuit to activate a column address. The latency indicates how many clock cycles it takes for the memory module to read or write a column of data from the memory module and return the data request to the CPU. So basically, it's a measure of speed, how long it takes to put the marker in memory and then take it back out. Timing sends memory to the circuit to activate the column address, and then the voltage level the motherboard provides to the memory itself. Gamers, it says gamers often increase this amount to provide more power to the memory modules, typically add extra cooling to keep the modules stable, because if memory overheats, it will become unstable. Common RAM issues, computer crashes, system lockups, unexpected shutdowns, ESD, electrostatic discharge, overheating, or other power problems can do that. Registry writing to bad memory, general fault protections, all can cause that. Overheating probably is going to be the one that is I guess the one that we would probably see the most. Memory errors on the screen. Memory address errors at the boot time. Applications require large amounts of memories that don't release memory. When an application gets done doing its thing, it's supposed to give up the memory that it's using. If it's not, that's called a memory leak. And what happens is you keep using more and more and more memory until eventually you run out of memory. And then the other applications can't get it. Applications should be tested to be sure that they don't have memory leaks. But a memory leak is when an application doesn't give up the memory that it's using when that application gets shut down. Blank screen on boot up. Memory is not correct for the system. The module is not fully inserted in the slot. If the memory is not fully inserted, I'm going to say you should get a beep code. You may or may not, depending on how far in it is. But remember that memory, that there is some memory, is one of the things that is checked at post. CPUs, the computer does not boot post beep code sound. Here we go. Cannot communicate with the memory due to the memory being improperly installed or the BIOS not recognizing the memory. Some or all newly installed RAMs not recognized. We've exceeded the amount of RAM that is allowed on the motherboard. That's going to be again in the documentation. Wrong memory type. Memory was not installed in a proper sequence. Documentation, again, you can guess that on those, if you got black, blue, that's going to be the black and then the blue and the blue. But you need to check the motherboard documentation to really determine what order this stuff should go in. Might need to leave empty slots between multiple modules. Might need to install modules in a different configuration. How to upgrade memory. Questions to ask: how much do I need and how much is currently installed? And I think the answer to Windows is about twice as much as you've got, regardless of how much it is. How many and what kind of memory modules are currently on the motherboard? You can look at them, and again, a lot of the people that sell memory, the websites have apps that you can run on your program you can run on your machine, and it will determine what memory type and how much you have and how much you can put on it. How many and what kind of modules can I fit on the motherboard? Motherboard documentation. How can I select and purchase the right modules? How do I physically install the modules? You physically install them today. They go directly down. You got to line the notch up, obviously, so that they'll fit. And then there's going to be little snaps on the end, and that's what all of this cutout here at the top is. That there is a little holder that snaps it into place that keeps it from backing out. Check the motherboard documentation, the ultimate authority, and on this one, the maximum 32 gig could take a DDR3 1600 or 1333, non-error correcting unbuffered memory. The online and manufacturers we talked about, there may be multiple options for what memory can go into your machine. And here we go to all you can get. Windows 8, 7 require at least 2 gig, but more is better. More and more and more is better. The RAM limit for a 32-bit operating system is 4 gig. 64-bit installation for Windows 8, 128 gig. For Windows 7 Home Premium is 16 gig. The limitation is a limitation of the operating system, not of the motherboard of the bus. The 4 gig is, but I think that we had a server, Windows, I don't remember which one, couple years ago, and I think we had 128 gig of RAM in it. We were using it as a virtual server where the students would have their virtual computers running on it, so it needed a lot of memory. How many, what kind of modules? Open the case and look how many slots. Again, look and see how many are filled. Review the module imprint, module physical size and notch position. Read the motherboard documentation. As a last resort, take the motherboard and the old memory modules to a good computer parts store for confirmation. And again, you can get you can download the app to so that it can be checked. Read the documentation. DIMM modules can be installed as single modules, but that's the single module access then. If the motherboard supports dual channeling, install matching DIMMs, and we've talked about that before. DDR3 support for triple channeling, matching DIMMs in the triple channel slots, matching everything, and if you can, including the matching of the manufacturer. Dual channel DIMMs, matching DIMMs in the 2 blue slots and matching DIMMs in the 2 black slots. When you do those, the channels, you want to match all even if you can't match the channels with memory, the memory within the channel should match, if that makes any sense. It's possible to use only 3 DIMMs in dual channeling. You must install matching DIMMs in the 2 blue slots and a 3rd DIMM in the black slot. And here we're kind of generalizing, but still look at what the documentation says. And again, this is for DDR3 memory. Motherboard using the triple channel matching stand. We've said that so many times, but the dual channeling, two matching SIMs in the blue slots. Farthest from the processor, leave the other 2 slots empty for the dual channel. And this one is something, install it in the 2 blue slots farthest from the processor. For 1 installed DIMM, place in the blue slot farthest from the processor. So if you want to go farthest from the processor and work your way towards the processor for these things. Okay, let's keep going and talk about some permanent storage. What we've been talking about, RAM is temporary storage. Power goes out, the storage, whatever's there, goes away. The RAM empties itself. It drains down. It's got to have a voltage to hold it on. The optical, and we've talked about these a little bit before. We'll do some more here. Optical, magnetic, solid state, and RAID arrays. RAID arrays are the thing that we really want to talk about here. We've talked about the optical a little bit. Magnetic media and how a disk works, the read-write heads, the platters, goes back and forth, the delays that are in it, and solid state drives. We looked at one of those, what they are. Solid state drives, basically EEPROMs, electrically erasable programmable read-only memories. We don't have the rotational delay and the seek, the head seek delays in those. Internal storage considerations. Do you have existing internal storage devices? Does the device need additional drivers? And hard drives typically don't need a whole lot of drivers. The SSD didn't either. The BIOS detected it. CDs may, DVDs may. They have in the past. Does the computer have an available power supply cable to supply the power to the device? And that can be an issue. Do we have enough? And that goes back to that question that was on the little question set that we used. Do we have enough cables? Do we need a sufficient number of them, as many as we can get? Does it have an available drive bay for the storage device? Is there some place to mount it so that we can get to it that has an opening on the front of the case, or someplace on the case so that we can get the media in and out? Or if it's a hard drive, does it have some place to mount so that it's not bouncing around in the case? Because the heads, and we talked about, I think it was 10 microns is somewhere around that is the clearance. Thank you. I guess if I unmuted myself, it would work better, wouldn't it? Thank you. So let's try that again. Does the computer have existing internal storage? Does the device does it need additional drivers? Is there an available power supply cable? And that goes back to the question that we talked about on those questions, on the questions earlier, that one of the things that we wanted in a power supply was a sufficient number of connectors on the power supply. Does it have an available drive bay, someplace that we can put the device itself? If it's something that we need to access a DVD, for instance, or a CD, is there a place on the front to put it in so that we can access the media itself? If it's a hard drive or an SSD, is there someplace to mount it in the case? We don't want the hard drives bouncing around in the case because the heads have can you guys hear me now? But so the heads are like 10 microns, 10 millionths of an inch clearance. So any kind of motion can cause damage, bounce it off of the magnetic surface, and do damage to the surfaces of the hard drive. Necessary data cables and a place to connect the data cables on the hard drive itself. Does the replacement device interrupt the airflow in the case? And we talked about that. EIDEs, IDE drives with big flat cables, the ribbon cables, sometimes could if you weren't careful how you set them up. External storage, good idea. Do you have a place to plug it in? What interface does the external storage require? USB, FireWire, eSATA? Do we have that particular connector on the motherboard? Do you need a cable to connect the external storage to the computer? And if you do you have that cable? Do you have an available source of power for the storage? Do you need an available source of power? And we have a USB here, a little USB drive. Sometimes the USB devices need a power connector, and sometimes they don't. I'm going to take mine off here, and it's going to talk to me, but when we do these things, the external hard drive, and I think this one's I don't know, a terabyte or something, just has the USB. It takes its power from the USB connector, and if you look into it, it's blue. It's a USB 3, although I'm not sure that I'm connected to a USB 3 port on this computer. Backward compatibility of USB 3, if I don't have it, it's backward compatible to USB 2. For USB, use USB 3 if you have it. Disk management, we're going to look at this in a minute. I want to go through the slides on RAID and then bring up a virtual machine or Windows Server and do some disk management. What can we do with the devices themselves? So we'll look at that, but this is what the disk management module looks like in a Windows device. RAID, redundant array of independent disks, used to be inexpensive, used to be for a while whatever you wanted it to be. It's different than what they call JBOD, just a bunch of disks. Just a bunch of disks. We'll talk about some of the ways that we can use disks, but RAID is supposed to give us redundancy of the data so that if we have a disk failure, we still have our data. That's not going to be the case in all of the versions of RAID that you're supposed to know about for this test, and those are RAID 0, 1, 5, and then 1, 0. We're going to talk about them here right now, and then we'll make and then make a RAID 0, 1, and 5 on the Windows machine. Two different RAID standards, two different ways to create a RAID. One is software based, and that's what we're going to use on the Windows Server. It's a software feature no special hardware, usually lower performance than a hardware based. And typically we're going to find in almost everything IT that hardware is going to be faster than software. This is a RAID controller, a picture of one here, and you can see it's got a connection for 1, 2, 3, 4 disks. The RAID controller makes independent disks appear as one drive. The software RAID is going to do the same thing, that we put these things together and address them as a single drive letter. The advantage to the hardware RAID is it's configured outside of the OS. The operating system doesn't really know about the RAID controller. All it knows about is the drive, that it has this big, enormous drive out there or whatever we're going to do for it. The hardware-based are going to be a higher performance than the software-based. We talked about the RAID levels, and I've got individual slides on each of these, but overview, RAID 0 implements striping, process of spreading data across multiple drives, so that it's going to be fast, but it's going to be the one that doesn't have the R part of RAID. There is no redundancy in RAID 0. And I guess one of the, and I just got a note from somebody that says this is on the exam, so this is on the exam. RAID 0, and the easy way to remember that, the RAID 0 has 0 redundancy. You need at least 2 physical disks in order to implement it. And the largest size RAID 0 partition that can be created is equal to the smallest available partition. What that means is, go back to my bad drawings here, if we have hard drives and we have, let's say we have a 10 gig and a 50 gig, the largest partition we could use would be a 10 gig, which would give us 20 gig on this thing. The rest of this we can use for something else, but it can't be part of the RAID. So the individual RAID partitions or volumes can only be as big as the smallest ones. So if we had a, say we had a 10 gig, a 20 gig, and a 25 gig, and these are just numbers made up, obviously. Then what we would have would be a 10, a 10, and a 10 for these things. The other disk space in here, the 10 on this one and the 15 on this one, could be used for other things, but it couldn't be used in that RAID. So the largest RAID partition that can be created is equal to the smallest available partition in the drive set. RAID 1 is 2 identical drives for mirroring or duplexing. What we do is make 2 copies. We make a copy, and this one has true redundancy. So we have 2 writes on this thing. RAID 0 is fast, but it has 0 redundancy. This one has lots of redundancy, but it's got a slow write because we have to write everything twice. We have to write it to both drives, make the drive and a copy of it. Mirrored drives share the controller. Duplex drives share individual controllers. Mirroring and duplexing, what this is talking about, we have a drive, we'll say drive controllers here. If we have two drives, 2 hard drives, good hard drives there, right? 2 hard drives on the same controller, then it's going to be mirrored. If we have 2 controllers with a hard drive on each one, it's going to be called a duplex. The issue here is if we lose a controller, we're still in business over here. If we lose this controller, we lose both drives. So duplexing, a little bit more redundancy. RAID 5 spreads it spreads the data across multiple drives like RAID 0 does, but it creates what's called a parity stripe. It's some code that if we lose one hard drive, and we can only lose one hard drive in RAID 5, if we lose one hard drive, we can recreate the data from the parity stripe. If you lose 2 hard drives, regardless of how many you have, if you lose 2 of them in a RAID 5, then you rebuild the RAID and restore from backup. RAID 1 0 is a combination of RAIDs 1 and 0. So what it has, and I've got a picture, it'll be a little bit better, but it is a stripe. We have the two with a stripe, and then we mirror the stripe so that we have speed and redundancy at the same time. And it requires a minimum of 4 disks in order to implement that. So RAID 0, again here, the file blocks split among the drives, high performance, gaming, 0 redundancy. Ideal use, RAID 0 is ideal for non-critical storage of data that have to be read and written at high speed, such as an image retouching or video editing station. And I think that gamers would probably like the speed of the RAID 0s. Okay, this should be a RAID 1. Let's put that in here. RAID 1. File blocks are duplicated down here, and this is actually going to be mirrored. These things, we've got 2 different mirrors on this. We have the RAID controller mirrored here. These 2 drive sets would have the same data, and these 2 drive sets would have the same data. Separate drive sets. File blocks are duplicated. High disk utilization because we need twice the number of disks because we're saving everything twice. Required disk space is duplicated. High redundancy. Drive failure. If a drive fails, one of these goes down, we're still in business because this one's still operating. Does not affect the data. If a drive goes down, and this does work, then we can replace that drive. When we replace that drive, bring the RAID back up, the data will be automatically copied to it because the RAID keeps a separate copy of the device. So it does those things. RAID 1 is ideal for mission critical storage. Accounting systems also suitable for small servers which have 2 data drives. We did use RAID 1s on a number of our servers, and disks fail. So that is a good thing. So we do that. We have these issues here. So this one is the one that really has lots of redundancy, but it does have some speed issues because we have to write the data twice on it. The RAID 5, and I forgot, I didn't put titles on there. Let me put them on as we go. RAID 5 is basically a RAID 1. We split it, and these guys used to have a motion one, which I liked a lot. They'd have the little data packet come out here. The data would come out here, and some would go here, some would go here, some here, some here, and some here. So in this one, we've got a whole bunch of disks that we can put data on, and it gets split up by the controller, and the controller puts a little bit of data on each of the drives. In this one, we have the parity bit that goes on these things. When we do that, we're able to rebuild if 1 drive fails. If 2 drive fails, we have to go to our backup. We also lose some disk storage, and there's a formula, n times n minus whatever, but what it basically amounts to is regardless of how many disks you have, you lose 1 disk worth of storage. 1 disk worth of storage goes away. So if we have these things, and again, we're going to have equal size volumes of this, and it's going to be the smallest of the ones that are available when we create these things. So if we had let's do easy numbers, a 10 and a 10 and a 10 and a 10 and a 10, and we'll see this when we create them, 10, 20, 30, 40, 50, we would actually get 40 whatever's gigs worth of storage. We lose 1 disk space worth of storage when we do that. Good for all-around system that combines efficient storage, excellent security, and decent performance. It's ideal for file application servers that have a limited number of data drives. And later on, just like we used the RAID 1, the mirror on drives for a while, we eventually got a RAID 5 controller, and it worked very well. If you do lose one of these disks, the thing that will give you a hint is that your disk access is going to slow down on it, because it has to create that other disk's data, the other data from the parity stripes. So it's going to slow things down. And it is a little bit slower writing because the parity has to be generated every time it makes a write. The RAID 1, 0, RAID 10, and there is a RAID 0, 1. 1, 0 is a very high level of reliability, the speed of striping, and the redundancy of mirroring. What we do is we create a stripe and then mirror it. So what we have here is a stripe, obviously, and here we have a stripe, and we mirror these two so that we create redundancy. Actually, this one is mirroring and then striping. What usually happens is whichever one is listed first is the system does first. So it will create the RAID 1 first and then the RAID 0 after that. So first it would create the mirror, the RAID 1, and then it would stripe within that. For the RAID 1, 0, we need at least 4 hard drives in order to make it work. So before we do that, let me bring this server over here, if I can get back into it. It has, I hope, if it'll wake up, it has on it a number of drives down here. These are unallocated, nothing on these, and they're also not activated. So the first thing, they were offline. I did bring them online. First thing we need to do is initialize them. Let's just go ahead and initialize them. But if you see here, we can initialize them as either MBR, master boot record, or GUID partitions, GPT. And the note says there that the GPT style is not recognized by all previous versions of Windows. It is recommended for disks larger than 2 terabytes. Or disks that are used on titanium-based systems. So we'll go ahead and activate these guys. Once I do that, I can now create a new span volume. What a span volume does is puts disks together. If I had, and I will just draw them as columns here, a disk here and a disk here. If we had a 10 and a 10, what a span would do would span these two things, put them together, no redundancy here, but make me a 20 volume. So they're dangerous because if the span fails, regardless of how much data is on it, it's gone. And I've seen that happen too. That was our very first attempt in our servers before we were RAIDs. We had those, and they would fail and all your data goes away. It's very, very frustrating. I know a couple of you had to come in late. What I say is I've been recording this, so I'll post it tonight if you want to go back and suffer through it. We have the new span, a new striped volume. If we do a new striped volume, and remember a stripe requires 2 disks, right? I don't have a next yet. What this says is that I've got the total volume size in megabytes is 4957, maximum 4957. The amount of space in megabytes, 4957. So if I add one of these things, I get the next. I can now do that. I think what I'm going to do is make these really small. This is what's available. The total size in megabytes and the amount of space in megabytes Let's see if we can make this. So my keypad doesn't work on this thing. 10,000. So we're going to use 2 disks, and we're going to make a 20,000, 20 meg hard drive. Doesn't matter what the sizes are. You would make them obviously what you would need. Next, assign a drive letter. It'll be the E. And then it's going to be an NTFS partition, allocation, allocation unit, the volume label. Let's call this a stripe, just so that we can see what's going on here. STRIPE, right? So it's going to be a stripe. We'll perform a quick format. Enable file. We're not going to do compression. So when we finish this thing, the operation you select will convert the disks to dynamic disk. Yes, it will. Because you have to have, in Windows, they have to be dynamic disks in order to do that. So now then, we have this thing, and it's doing the quick format. We have the stripe. We can see we have a stripe here with these 2 disks. So let's go down here and let's do a new mirrored volume. What I'm going to try to do is create all of these things here. Again, I can't do anything until I add a disk. And let's see if we do here. Oh, yeah. It doesn't like my number pad. Do the 10,000 again. But you notice when we do the 10,000, we lose 1 disk. We lose half of our storage because total is still 10,000 because we have to have twice as much storage as we need because we're making a copy of everything. So we can do this, we'll assign it F, and let's call it the mirror. Mirror, and we'll do the quick format for it also. We'll convert it to, yeah, because this one had not been converted to the dynamic disk. Yeah, it's still, yeah, it's still working. I thought I had lost it there for a second. So it's now formatting it. I have a mirror, because this is the disk that I picked for the mirror. They don't have to be lined up here. The next thing we want to do is a RAID 5. This one, you can't do a RAID 1.0 in this thing. So we do a RAID 5. I still don't have the next because I need at least 3 disks for a RAID 5. And we'll go back here and do the, see, let's see, did it do its thing here for me? Let's go back. Yeah, let's cancel that and do that again. Let's not, because what I want to do, new RAID volume, because I've only got 20 available up here. I add this, and then it says the total volume size in megabytes, 20, and then if we add the other one, 41. We're going to lose 1 disk worth. And you notice that we had these 30s here, but I had a 20 up here is the smallest, so it automatically reduced the size that was available to the smallest partition that was available, which was this 20 meg here. Let's go ahead and make let's make this, and we have lost 1 disk worth of storage. We had 20, 20, 20, and well, we are at 41. Let's say the amount of disk space on each of these. Let's go ahead and make those 10,000 also. 10,000. Okay, and it's going to be the G drive, and we'll call this one RAID 5. ID 5. And we'll do the quick format on it. So it is then, I hope, going to take up the space on those 3. It takes some of these. It takes a little longer than the other ones. On the mirror, it actually does the mirroring when we do that. If this doesn't start in a few seconds, we'll bring it back over. There we go. So now we have the RAID 5. We have the 3 disks here. If one of these disks went down, this would still work. If 2 of these disks went down, then we would have to rebuild our RAID and restore it from backup. The mirror, 1 disk goes down, mirror is still good. I think that we can take this offline and let's see what happens here. Okay, offline, it says that we have a problem. We have a missing disk in the RAID. What we could do, and this would just be for the RAID 5. We have the mirror. We can still put something in it with a new folder just to show that something will go in it with the mirror there. The stripe, we didn't affect it. It would not be there if that were the case. And the RAID 5, we can put it in because of the redundancy. If another disk went down, we would have some real issues. We could then put this disk back online, and in a few minutes it should actually repair itself. We're not going to wait for it to do that, but we have failed, saying we get the notice here that we have a fail redundancy on these things. I think that we have to reactivate the disk maybe. There's a wrong disk on it. Anyhow, get the idea of how RAID works, and then we will reactivate this disk. That one got reactivated, except it's my machine's being. I'm over stressing the physical machine here, but that's the way that RAID works, and hopefully a helpful little deal there on demo on creating RAID, software RAID. We have the hardware RAIDs and the software RAIDs on these things. System firmware, special software, stored memory chips, communication between the hardware and the operating system, accessed each time the PC boots up, and we've talked about the BIOS. The traditional firmware had some limitations. Didn't have support for hard drives. The hard drives just kind of all exploded at once in order to be able to do those things. So it didn't have that. And again, if you look with it back to the GPT and the Windows, we have the GUID partition for it. Plain text, non-mouseable interface. And we all have become, me too, dependent upon the mouse itself. So we have to use the arrow keys back and forth in order to use the BIOS. And again, in the share there is the BIOS demos if you want to use those. UEFI, Unified Extensible Firmware, fixed some of the limitations of BIOS, larger hard drives, GUI interface, offers remote diagnostics and repair, and a secure boot feature. The secure boot feature is something that's supposed to help us in the security world. And we had those passwords in there. We had the user passwords and the what was it, supervisor password. You need to look at the proper term on those passwords in order to either allow changes or to allow the system to boot. Firmware upgrades. This is one, yep. If you're going to do it, I did it to a tablet today and did it and say, I'm not really sure I want to do this, but that's all you can do with them. And it takes forever for it to get in. You say, well, did I break it? Did I not break it? But I told you my experience with the router, and they said, oh yeah, there's a new firmware. Just click here and it will fix everything for you. And I clicked there and it made it a doorstop. Some point, you may have to do a firmware upgrade, but only when you really need to. And when you do, be sure you have stable power, because if you lose power during the upgrade, it can make the machine a doorstop. Although, again, and I think we said this before, new BIOSes tend to have backup, UEFI, tend to have a backup copy there so that if the first one gets ruined, you actually can restore from the backup. Enable advanced plug-and-play power management, comply with the vendor support requirements, all of the things that we do. System components that can configure through firmware, the RAM, the amount of RAM that it will handle, hard drives, how big, what kind, optical drives, whether we have its CPU, maybe the CPU types that we would have on it. The configurations, I think we probably have looked at these, the general, the security, enabling and disabling, and security, I guess is a big word, password management, full drive encryption, TPM status. The TPM module, the TPM is storing a certificate on it that will mark the disks, basically. Laptop tracking software and configuration. They talk about low jacking a laptop. It's a piece of software that actually gets embedded into the BIOS or UEFI and then written to the hard drive. Somebody tries to change the hard drive, it gets written back. So you can track the hardware. Big deal for companies, some companies, particularly people that travel with laptops that have corporate information on them that could be damaging or significant. Enable, disable devices on it. Clock speed. You can change the clock speed if you're going to overclock. This would be where you would do it. System configuration, integrated NIC, USB controllers, other ports. We can turn off the on or off integrated NICs, on or off integrated video. Manage the video controller settings. CPU settings, virtualization support. If you're going to run virtual machines, and that's probably one of the problems here, I haven't not been into my BIOS, and I actually don't know if it supports virtualization. The BIOS can be, UEFI can be set, I'll say BIOS forever because that's what I was brought up with. It has an option to turn on virtualization support, which gives a better utilization of the hardware by the virtual machines. Power management, maintenance, the asset tag maintenance, service from the outside vendors. The asset tags, the Dells have asset tags that allow them in if you allow them in. Also will tell you what is and can be on your particular machine. You can go to Dell, put in the asset tag management, will tell you what originally came in the machine, what, how much memory you can do, all of the things that we've talked about. They've tried to make it simpler. Secure boot, it's available in the UEFI version 2.2. Checks drivers before they're loaded and does not allow unsigned drivers to be loaded. Microsoft has tried to do that in the operating system also, but unsigned drivers can be an issue, and this is the way malware gets in frequently. Support in the Windows 8, 8.1, some Linux distros, Windows 10 on up, and the servers themselves. Enable by default. You may need to disable it, and you can't disable it in Windows RT if you have the Windows RT, which is a restricted version. It's a restricted information set on this. Built-in firmware diagnostics may be there, and this is one that is found in a Dell hard drive. The diagnostics that can be run on it may be available. This is a pre-boot system assessment for the service tag, whatever the service tag is here, if you can read it. All tests were passed, so there may be some of those things. What can it monitor? Temperature, fan speeds, intrusion detection. When the case cover is removed, the sensor alerts the firmware. Voltage, the VCC memory check, the AGP voltage, and remember, AGP Advanced Graphics Port is a dedicated old graphics system. Verify the clock accuracy, verify the CPU speed of these things. Drive troubleshooting tools that you may need screwdriver. I showed you my little kit the other night. It had some screwdrivers in it, a couple of nut drivers. Tweezers are a big deal, and the little thing to hold the screws with. I just call it the screw holder that has a pincer on it that you can get them into tight spots, and also pick up things that you drop in a case, because it's going to be, you're going to do it eventually. External enclosures ensures that you protect and provide power to the hard disk drive. Check disk is a utility to check the file system for errors, check and correct. Boot rec enables you to perform a systems recovery tasks for Vista and Windows 7. Disk part says a superset of commands available in the disk management tool. Disk part is a command line management for disk management. When you do that, it's really cool. It's really quick, and it's really easy to mess up stuff. So be careful with that. Format obviously prepares the disk partitions for a file system, and that's the answer that I've seen forever on what does format do. It prepares the partition to accept file systems, to accept files. Fdisk creates and manages disk partitions. Fdisk is going to wipe out everything and create new partitions. File recovery software. We used to have an undelete in Windows, but they took that out several iterations ago, where you could recover deleted files. There are file recovery softwares available, different pricing. I used one time where the partitions got destroyed on a relatively large hard drive, and it recovered all but one file. So I thought that was pretty good. It was called Get Back, I think was the name of the software. Hardware symptoms: failure to boot, post errors, the drive's not recognized. A lot of these things we've talked about. Drive read-write failure, computer won't boot, grinding noises are not good. Clunking noises in hard drives are not good. Clunking noise, if you can still get the data off, make a copy of it, back it up as quickly as you can, because that's kind of an indicator that the disk is failing. It's the hard drive, it's the read-write heads getting into the what's called the landing zone, the LZ, which is where it goes when the computer shuts down, so that it doesn't damage the disk surface. Possible data corruption, slow performance of the hard drive, defragmentation may be what's needed. The disks use the first storage area that's available. So if you have a file that's bigger than that, it's going to use that one, then it's going to go to the next storage area that's available. So what we wind up is with little bits of the file all over the hard drive. Makes it harder to access it. Defragmentation fixes that. And if you use defrag for the spinning hard drives, yes, you don't need to and should not defrag SSDs. External drive issues, and that for me has always been not plugged in or not plugged in right. Removable drive issues, and when we looked at the drives in the control panel, we had two options there for the removable disk. One was for the quick removal, and the other was for the reliability and speed. And if you configure it for not quick removal, then you're going to need to use that eject option. OS not found, usually going to be something like you can't find the active partition on it. BSOD, blue screen of death, that one, it may be something that's repairable. Well, can you get into safe mode? If that's the case, try to check disk. The check disk /R will repair anything that Windows can repair. RAID not found when the computer boots. The RAID may not be configured in the system firmware. Motherboard doesn't recognize the RAID. Stops working. Settings have changed. The motherboard And this is one motherboard may not support RAID. If it stopped working, then it probably supported RAID initially. RAID controller firmware is not configured correctly. Typically, what's going to be if it stops working is you got a drive problem, you've got a controller problem, or in fact that the settings did change on it. Smart self-monitoring analysis and reporting technology. What this does, it anticipates storage device failures. It'll tell you when a device is about to fail. We had that happen on some drives, and it's going to fail, going to fail, going to fail, and the drive's in a RAID array. So we're waiting for it to fail, waiting for it to fail, waiting for it to fail. It says, I got another note here. It says, this is also on the exam for CPU and RAM tools. Let me back here, CPU and RAM tools. I guess we're in these. So those kinds of things you can expect on the exam. And we finally did get to the end of this. Are there questions?